private API endpoints on the AWS Marketplace. Currently, we have around 58 plus endpoints available on the AWS Marketplace, and we are still trying to add more. They range from medical LLMs from 7B to 70B. We also have vision LLMs. We also have the identification endpoints there for 8 languages from English, Spanish, German. The de-identification models also have multimodal capabilities in terms of we have endpoints for de-identifying PDF files, images, SVS files, DICOM files, etc. We also have medical translations on the AWS Marketplace for English to Spanish or English to French and vice versa. We have entity relation assertion detections, NOR pipelines, relation extraction pipelines, or certain detection endpoints. All those are available on AWS Marketplace as of now. The thing about the AWS Marketplace is you don't require a JSL license to get it working, right? So typically, if you have used our Johnson S products, you would know that most of our products are, for most of our models are proprietary, and you don't require a JSL license to get it working. But the thing about these cloud providers, we have a partnership with them, and our products are there without the use of a JSL license, right? So everything is taken care by the AWS Marketplace itself. So you go there, you subscribe. I'll show you the process in a few minutes. So another thing to notice is the deployment aspect. You don't need to write any code to deploy. You can, but with AWS Marketplace, with a few clicks of the buttons, you can have the endpoints running on your environment, which I'll show you. And there is, as I mentioned before, everything runs on your AWS infrastructure, right? When we create the listing, we provide the best recommended infrastructure that would be required to get an endpoint up and running for that particular model. And once we have that, when you launch an endpoint, you have the option to pick the instance you want based on your needs from the list we recommend. On AWS, you have the capability for real-time and batch transform jobs. So real-time jobs, real-time inference jobs, or real-time inference endpoints are useful when you require high throughput, right? So you have a request and you want the response within some seconds. So in that case, you have the capability to use a real-time inference endpoint, which is you send a request, you get the response right back. So if you have a chatbot like app that you need to create, or just you want to send real-time requests to the endpoint, then real-time inference is the choice for you. Batch transform jobs for when you have a lot of documents, right, and you want it to run it through our pipeline or from our model on that endpoint, right? So in that case, you would typically use a batch transform jobs where you store a lot of data on the S3 bucket and it gets processed through our endpoints using batch transform jobs. I think they have some batching strategy there as well. So since we use AWS, these are provided out of the box. You may or may not use it based on your use cases. Another advantage on the AWS infrastructure is the integration with AWS services, right? So you can constantly monitor what's going on with your endpoint using CloudWatch and see the logs using CloudTrail. You can set up alerts, everything. And it's totally integrated with the AWS services, right? So to find, I have added a link here, which will point you to the AWS Marketplace page, right? If you click on this page, it will redirect to the AWS Marketplace, and you can see all the listings we have provided on the AWS Marketplace, right? So you can see we have the identification for PDF, we have medical and medium, we have medical and small, 14B. I'll show you the process of how to deploy a model on the AWS Marketplace, okay? So for AWS, let's deploy our medical vision language model. We have a 24B medical visual LLM model. So let's look at this model. So this 24B parameter vision language model combines both medical expertise with visual comprehension capabilities, right? So it can take images, right, of specific formats like JPGs, PNGs, and it's able to process those images and text as well. And the model presents high performance in medical tasks while adding the ability to examine visual content such as X-rays, MRIs, pathology slides, and medical diagrams. So it has a 32K context window, and you can see the accuracy and the performance metrics that have been measured and put on the listing. To get started, and to subscribe to your model, you need to click on the continue to subscribe button. You do need to be logged into your AWS account, by the way. Right, so I'm going to quickly log into my AWS account. So once you are logged into your account and you click on the listing page, you will be directed to this form where you are going to subscribe to the product. Prices are per hour, right? So you click on the accept offer button, right? This starts a subscription process, and the listing or the endpoint will be available as a marketplace subscription on your AWS account. So once you're subscribed, you'll see a screen like this thanking you for subscribing, and now you can start using the product. To use the product, click on the continue to configuration at the top. This redirects you to the Azure. This redirects you to the AWS launch panel, right, where you can have option to how do you want to start an instance. So what happens is when you subscribe to the model, an ARN or a resource identifier is created to you, and AWS resource number is created for you. You need to be aware of this resource number. So this is your model package, right? So you have different options to start the model. You can choose cloud formation, you can choose SageMaker console, or you can use AWS command line interface as well if you want programmatic access. I prefer to use the SageMaker console, which is the easiest one, but you can use any launch methods that you are aware about, right? So even on the SageMaker console, you have two options. One is the real-time inference endpoint. One is the batch transform job. So as I mentioned before, real-time inference is useful when you want to have you want to send the request and get the response right away, right? And whereas a batch transform jobs is useful when you have a data set and you want your you want your data to go through the model on a batch request, and you don't care about the response of the model, right? So it does take time. For LLMs, it is generally better to use real-time inference endpoint. So to get it started, just click on create a real-time inference and click on view in Amazon SageMaker. Now this opens a form to create an endpoint for your subscription, right? Basically, to create an endpoint on AWS, first of all, you need to create a model. The previous subscription that you did provided a model package. Now, first step is to create a model out of this. So let's use the model name 24B Visual model. It can be anything you want. You do need an IAM role just to make the vision model. We need to download the proper S3 artifacts, the artifacts from the S3 bucket. So make sure you use the IAM role that has the permission to AWS Marketplace, right? After this, you can click on the next button. The next section is the continuation for the create endpoint. To create an endpoint, you also need an endpoint configuration, right? So it's asking for endpoint name. So let's use 24B vegan endpoint. Right, it can be anything you want. You have the option to either create a new endpoint configuration or use an existing one. So I'll create a new one for this one. I'm going to change the instance type here. So I'm going to use one of the larger ones, but all those are also supported, by the way. Okay, once you're happy, just click on the create endpoint configuration button. This will create an endpoint configuration, which you can reuse later on as well. Next step is to click on the submit button. Right. Once you create an endpoint, it will show you the success message. It does take some time for the endpoints to get started because AWS needs to provision the infrastructure download the models from the S3 artifacts and launch and container, right? And after the endpoint is created, let's wait for it. I'll also have a demo environment where the endpoint is already loaded. So I'll be using that to show you how to use the endpoint. Okay, I'm switching to the demo instance I have, demo endpoint that I have. It's the same 24B model we subscribe to. So I'll be using this model and showing you how to use it, right? So if you have SageMaker Studio, you could actually call it via a UI. But since we have this URL, AWS allows to use SageMaker SDKs to interact with the model. Right? So you see we have uses here. Now, with every listing, you have an notebook that is attached on the listing page to see how you are going to utilize this model, right? And for this listing, we have the notebook on our Spark NLP workshop playbook. So it's on the SageMaker models, the Vision LLM, right? So it's information BLM 24B. Okay, this one. This notebook you can use to start interacting with the model. Basically, you have the steps required to get everything from subscription to start utilizing the model. So I will use this model or this notebook to show you how to call the API. Okay. Okay, let's start. Okay, so let's use this notebook. So I go to a notebook, a SageMaker notebook instance. I'm going to launch a Jupyter Live instance. Using a SageMaker notebook instance is easier because you already have pre-configured a SageMaker session and you can use directly that to access the endpoint, right? But it's not the only case. You can use any notebook or any Python shell or any programming language to get a SageMaker session with the proper credentials that has access to the endpoint that you just created, and you can just start running it, right? So this is a notebook, right? So here what you need to do is you need to identify which endpoint you're going to call, right? So our endpoint is called 24B Vision endpoint. So I just put the endpoint name as here. So I'll start this. So this is creating the required SageMaker session, the account ID, the bucket if you need, the SageMaker runtime, which is important. So basically, this is using both the 3 API to get to initialize those sessions from the SageMaker notebook instance, right? And as I said, it doesn't have to be a SageMaker notebook instance. If you have the proper AWS credentials, you can do it from any both the 3 API or any notebook or from your local computer as well. To invoke the real-time inference, SageMaker provides us this invoke endpoint function on the SageMaker runtime client, right? Here, you just need to provide the endpoint name as a parameter, the content type it accepts, and the content type it is responding back with, right? And you just need to send the body, which is the record. So I just created a helper function here. So I just create a system prompt as well that's going to instruct the LLM to perform based on the prompt, right? So first of all, I'm just asking a simple question: what should I do if I have a fever and my body aches, right? So you create a payload like this. As I said, this model, OPT/ML model, is required to make it compatible with OpenAI's input format. This is basically the place where SageMaker mounts the model, right? And these are the messages. So I have created a system prompt based on this, and I'm passing the prompt as a max tokens is the maximum number of tokens that the LLM is expected to return, right? And temperatures is about the randomness of the answer, right? It increases or decreases the randomness. So this is fairly common for all LLMs. We have the same thing here as well. So I'm just going to call the invoke endpoint function. That's the function I did, and I'm going to invoke the input, right? Okay. So the question was, what should I do if I have a fever and my body aches, right? So it's going to send requests to the LLM, and all our LLMs on SageMaker are via Docker containers. SageMaker mandates that everything runs on a Docker container. So the LLM has responded. So immediate steps to take: monitor your symptoms, stay hydrated, rest, over-the-counter medication, go into sick medication. So basically, the LLM has returned detailed analysis of what should we do when we have fever and aches, and conclusion. And it will also provide conclusion. Fever and body aches are common symptoms that can be caused by the variety of illness, right? So yada yada yada. So basically, you can basically what I'm saying is the LLM is responding right on the SageMaker environment. So next, I'm going to ask another prompt. This was our chat completion API, by the way, where you have the messages format. Right, these are the new or the standard ones nowadays. Right. Previously, we also have support for the text completion API, where you just pass the prompt directly. So I have asked here a question. Based on the description, on 20-year-old pregnant woman at 20 years gestation presentation. She states the 1 day cycle. She feeling notable and characterizes. So, what is the following best treatment for this patient? I'm asking based on this, right? So, and these are the options that LLM has to work with, right? Okay, the endpoint has responded and it has answered. Therefore, the best treatment for this patient is nitroglycerin, right? So, it's taking this context. The patient is a 20-year-old pregnant at 20 years. So just implementation. So the best treatment for the UTI implementation is nitroglycerin. And so it's providing an explanation as well, and it's saying that the best answer is nitroglycerin, which seems correct. Okay. Next is the vision capabilities of the model. So this is an online vision, meaning the LLM is going to see what's on this URL, right, and respond with and answer the question, what does panel data show? So let's first see what the image is, right? So I'm not from a medical background, so I might not have all the knowledge of what this diagram is showing, but I can see this is an MRI diagram of the brain, right? So to call this image to be processed by the vision capabilities of the model, you're going to use this type of format on a chat completion um, format, right? So you just need to pass the content, you need to pass the image URL, and image URL can be the link to the image, right? So you can pass this as an image. Everything is still the same, and you can invoke the endpoint. So we have asked the question, what does panel D use? So in this panel, right? Okay, so the LLM is thinking at the moment. It's the request is going in and it's going to respond back. So understanding the image panel, the provided image consists of 4 panels. So it has, so the LLM is now able to see what's on this image, right, on this PNG image, and it's able to describe what each panel is doing. Skimming down the penalty of speech vision, penalty label 8 weeks of follow-up. So yeah, this is the 8-week follow-up of the brain. As Ben also diagram 8 weeks after the initial admission. This image likely represents the chronic phase of the infarct. Basically, the LLM is able to see what's on the image and it's able to process it and give response. Another way you can send the image to the model is via using base64 encoded string, right? In case you want the endpoint to be running on a secure environment, you have network isolation in place. So what you would probably do is you have the image on your machine and you convert it to a base64 encoded string, right? Okay, so this is, I think, microscope picture of a tissue, and we are going to send this image to image to the LLM to process, right? So we're asking the question, what does this image D show? Right? So image D was showing, and you see to call the response, we have converted this image to a base64 string, and we are passing the same thing, image URL, but instead of the URL that we sent before directly as the HTTP request, we are sending the base64 string, which is compatible with OpenAI schema as well. So this also will be processed by the LLM, and then response will be returned, right? Of analysis of image, the visual image, the appears to be a section viewed on a microscope. Comparing also based on the option image is most likely the microcystic glands of the uterus. The glandular structures with luminous spaces and the specific leveling supports this identification. So yes, two ways you can send your images to be processed by our LLMs. One is via the image URL format, where you can send a publicly accessible resource, right? Another, it would be to convert it to its basic for encoded string representation and send it to the to the endpoint to be processed, right? The SageMaker endpoints also support streaming responses. They have a function called invoke endpoint with response stream. Here, everything gets responded back with streaming input. This could be helpful if you want to build some chatbot-like scenario where you don't want the response to be right away, but on a streaming basis, right? So it's the same mechanism here. I'm just going to show one of them. So we are just constantly the same prompt, same heading that we did before, but instead of we are sending an initial parameter called stream equals to true, which will provide the response on a streaming basis, right? So and this is provided natively by SalesMaker endpoints. All those things are the same thing here. It's the same image. You can, for the again the Bayesian capability, you can have streaming response with stream equals to true. This would also work. So let's see one of them. So yeah, same response, but on a streaming response. So response returned by the this function invoke endpoint with response string is a partial response where you have partial data and you could use that to create your streaming response. Okay. This sections, if you are done with your endpoint, you could delete them, right, to free up your instance type that has been used. Everything is else. Batch transforms we aren't going to discuss because we might run out of time. But this is useful, as I said, when you have a lot of data you want to store on your S3 bucket and just have the LLM run through it, right? And you just create a model of transformer job here, and it gets processed, and the output will be stored on an S3 bucket.